So I hope you like the sliders and the potato chips. I love it. I think it's great. So enjoy the meetup. Thank you to Google for hosting. And we look forward to seeing you at a future VMware meetup soon in December.
Awesome.
All right, so my name's Paris, by the way. I work on the Kubernetes team here. I do community engagement, specifically building upstream contributor programs. It's a great job, isn't it? So yeah, if anybody here wants to contribute or is contributing currently, please see me and you can chat my ear off about all things Kubernetes. And so first things first, Patrick, do you want to wave? Where's Patrick? Patrick Healy is sales manager with Mesosphere. And of course, we are so blessed and lucky tonight to have Toby, the CTO of Mesosphere, here to give our first talk. And then after that, we'll have Fawad with VMware to follow up. And then we can all leave for the night. Cool? You ready to do the damn thing?
Maybe.
Yeah. I think I'm the most Halloween in here for this Halloween edition, by the way. I was really disappointed at the lack of costumes. So
I didn't get the memo.
I know I should have.
Okay, thank you. It's great to be here. So I want to talk about DCS and Kubernetes and how they love each other, which may come as a surprise to some of you, at least the folks that have been following Kubernetes and Mesosphere and Mesos. But I really think the two fit together very nicely, and that's what I want to talk about tonight. What you might not know is that Mesosphere was actually one of the largest contributors to Kubernetes in some of the early releases. We wanted to make Kubernetes work on top of Mesos and DCOS early on because we just loved the project. It's great, a great API and great user experience, and a great community was forming around it. And to us, it has always made sense. And I want to convince you tonight that it really does make sense. So who here is familiar with Mesos or DCOS? Quick show of hands. A few people. Okay, so I'll kind of give some intro and some background also. And I have just a few slides. I like demos, so most of this is going to be a demo. But just a few slides to kind of set the stage for this. And first I want to talk about how Kubernetes and Mesos really are different and the different problems they want to solve, which is the basis for why they fit together. So that's just a screenshot of the Kubernetes website. So it says production-grade container orchestration, automated container deployment, scaling, and management. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. So it talks about deployment, scaling, managing containerized applications, right? This is the Mesos website. It says something completely different. It says, program against your data center like it's a single pool of resources. Apache Mesos abstracts CPU, memory, storage, and other compute resources away from machines, physical or virtual, enabling fault-tolerant and elastic distributed systems to easily be built and run effectively. So the two keywords here are program and build, I think. So it talks about programming against your data center. What Mesos really tries to do is it tries to be a toolkit or a foundation on which other distributed systems can be built and run. When the team at Berkeley built Mesos around 2009, they looked at Hadoop and MPI were sort of the big data tools at the time, and their theory was that in the future we'll see a lot more distributed systems, especially in the data science world. And so just like when we build any other type of software, we have libraries that we reuse, right? And so the team felt like, well, we need libraries, we need a solid foundation for building distributed systems. Because at the time, everybody that was building a distributed system was doing it from scratch. And so you had to figure out a lot of basic things like, how do I start a process on a different machine? How do I monitor it? How do I get notified when it crashes and things like that? And so these sort of basic things, these basic primitives for building distributed systems, that's really what Mesos is trying to solve. It does a lot more. So, one of the early papers from Mesos is called Dominant Resource Fairness. So this is the algorithm in Mesos, the scheduling algorithm that makes sure that all these different types of workloads that run on a cluster can get their fair share of the resources that are available. So this is something you really need when you run, say, a lot of batch jobs and then databases and latency sensitive production workloads all together on the same cluster. So the team spend a lot of time on figuring out these things. And so if you look at the stack, this is kind of our standard stack diagram for DCS 1.10. Kubernetes and Mesos really sit at different layers of the stack. Mesos is sort of busy with doing the low-level resource management, giving all the applications that run on top the resources they need. And so in our view of the world, where Kubernetes really fits in is right next to Marathon, which is a container orchestrator that we built. And so, the public perception is often it's Kubernetes versus Mesos. I really don't think that's a good comparison. I think the best comparison is really Kubernetes versus Marathon, because they both really built for container orchestration. So we built Marathon. Why then do we like Kubernetes? Well, the reason why we like it is we want to offer people choice. We think that platforms that are super opinionated about what you can run on them, aren't going to be successful. I think most platforms as a service are like that, right? They give you a small number of databases to choose from, for example, but we don't want that. And so that's why there's choice of a lot of different databases, a lot of data science tools like Spark or Flink, and even choice of different container orchestrators on DCOS. So by combining the two, Kubernetes and DCOS, this is really our goal. We think this is the easiest way to run Kubernetes outside of Google Container Engine. Container Engine is a great experience. It makes it really easy to start a Kubernetes cluster. It gives you all the things that you need to do around Kubernetes to put it in production, like logging and monitoring, networking, all those things. But if you're not on Google Cloud, you don't have those things. And that's why we put it on top of DCOS, because DCOS gives you those same things that Google Container Engine offers. So the high-level goals, we want this to be extremely easy to operate. So it's actually a one-click install to get a fully configured HA production-grade Kubernetes cluster. Highly available, it's secure by default. So it uses SSL and certificates. Built-in monitoring and metrics, load balancing, and it integrates with the DCOS network. What's really important to us is that this is 100% open source Kubernetes. We did not make any changes to it. So the same tools and tutorials you find online will work. It's the same API. We don't put our API in between. So it's really 100% pure upstream Kubernetes. And that was really important to us. And then lastly, it integrates, you can use all the data services that run really, really well on DCOS, like Cassandra and Kafka and HDFS and all those things. You can very easily install those things on DCOS the same way you can install Kubernetes, and then easily talk to them from your Kubernetes containerized apps, because they share the same network. When you start pods on Kubernetes, the IPs actually come from the same pool of IPs that DCOS manages for other applications. And the experience that you get is sort of a Kubernetes as a service. So a lot of folks we work with, they have a need to provision multiple Kubernetes clusters for different teams, or to run a dev and a staging and a production cluster. So it makes that really easy. Any questions so far, or did I confuse everybody? Please jump in with questions. It's way more fun when it's interactive. Okay. So this is kind of the thinking behind it. This is the philosophy. So let's look at it. So here I have a DCOS cluster. So this is running on Google Cloud. It's not doing much right now. I installed one service here. That's Cassandra. So I want to show you how to run a simple app that runs on Kubernetes and talks to a Cassandra database that's also running on DCOS. So I installed Cassandra already. I I did that from the catalog. That's where all the applications live. And you literally just go to Cassandra here and click deploy, and it starts running on your cluster. What's really important here is that when we run Cassandra or also Kubernetes or any of these other things in there on DCOS, it doesn't just spin up 3 Cassandra containers, but it comes with a Cassandra scheduler. So that's the first process you see here, the first container. So that's a scheduler that that's basically a Cassandra operator. So it has all the operational knowledge for Cassandra built in. So when you lose nodes and your containers need to get rescheduled, or when you want to upgrade Cassandra to a new version, or you want to deploy a new config to that Cassandra cluster, the scheduler automates all that, and it performs health checks to make sure that your cluster is healthy, and it deploys these nodes in the right order. So that's really important to understand. So the experience you get is literally like a Google Container Engine or any other cloud service where you just click a button or make an API call, you get a fully configured cluster. You don't have to write your own recipes to bring this thing up. And you also don't have to worry about upgrades and config changes and things like that. OK, now let's install Kubernetes. I'm going to do that from the command line because I'm going to pass in some custom config. So there's just a simple options file here. What it does is just says, I want 5 Kubernetes nodes, 5 kubelets. And what it also does is it specifies some service accounts here. So we're actually hooking into the service accounts and the CA that's built into DCOS to generate certificates for Kubernetes so that it can talk securely. So that's another one of these things that usually you would have to set up yourself, but DCOS kind of does it for you. So then to install it, you just have to say DCOS package install. The package is called beta Kubernetes right now because it's in beta. And just passing in this options file. And yes, I want to do that. It's also giving me a new CLI subcommand for the DCOS CLI, so I can interact with it. So this is important for when I want to update the cluster later or scale it up or scale it down. And if we go back here, now we see Kubernetes. The first container that you see running here is the Kubernetes scheduler, so similar to Cassandra. This thing will bring up all the Kubernetes components, etcd, API server, all the other pieces, and all the kubelets. And it's going to run 3 of each, 3 of all the master components, so it's HA. Like I said, it's going to generate all the certificates so they can talk securely. And it also uses the DCOS network for the components to talk to each other. So while this is provisioning, take a look at the secrets here. So you can see it generated a bunch of certificates and keys that the nodes use to talk to each other. And then if you look at networking, no networks yet. Wait a second. So you can see etcd is up now, 3 etcd nodes, and it's just going to continue to run all the other components. For this 5-node cluster, it should only take about 2 minutes to bring everything up. So like I said, one of the things that it does is also it knows how to heal the cluster when it breaks. So one of the things I want to show you in a little bit is we're going to kill an etcd node, and it's going to restart the node. And again, not just restart the container, but also run the right commands to forget about the old peer and then make sure the new one is healthy. Yes? It installs everything. So you can see all the master components like the API server, scheduler, etcd, but also the kubelet. So let's filter this. So you can see there's 5 kubelets running now. And it starts the kubelet with DCOS. Yeah, provisions the kubelet with DCOS. It's 3 masters. Yeah, so you can see 3 API servers and 3 controller managers. Yeah. Yeah. So Yeah. So basically what it does is it just runs all the Kubernetes components in a container, just like we would run any other workload. So it brings up a API server container, etcd container, controller manager container, kubelet container. Yeah.
So you just run Kubernetes inside DCOS local node.
Yes, that's correct.
So just one service.
Yep.
So it seems like DCOS simplifies a Kubernetes installation,
Mm-hmm.
but how hard is it to install DCOS?
It's very easy. We've actually put a lot of time into making that super easy. I mean, any installation is, can be hard, but the reason, the point is you only have to do this once, and then you can get access to all these applications in the catalog here, right? So installing Cassandra, Kafka, all of these things that you need to build a data-driven application. Usually you would have to figure out, okay, how do I install Kubernetes? Then how do I install Kafka? Then how do I install Cassandra, right? So you have to build your scripts and your automation for every one of these things. And they all have different characteristics. And some of these things are really complicated, like HDFS or Elastic have different node types that you need to bring up in the right order, that you need to heal in the right order, that you need to upgrade in the right order. And so you have to do none of these things on DCOS. Yes, you have to figure out how to install DCOS once, but everything else is super automated.
And then I'm seeing Jenkins down there or Cassandra.
Yeah.
When you say install these things, does this install them within Kubernetes so they're containerized there, or are they running?
On DCOS. It would be running on DCOS next to Kubernetes. Yeah. Who wants to go first? Ladies first?
So at the beginning of the presentation, you showed us the comparison, and you mentioned that it's Marathon actually that should be compared with Kubernetes, not really Mesos or DCOS.
Right.
So now you have Kubernetes running on DCOS, which is running on Marathon, or no?
No. So let me show. Yeah, let me show the stack. That's correct. So let's look at the stack diagram again. So Mesos is the base layer for everything, right? And when we're running Kubernetes on top or any other workload, it leverages, for example, security, so the CA, certificate authority, leverages networking. And so Marathon runs on top of Mesos, Kubernetes runs on top of Mesos, Jenkins runs on top of Mesos.
So you're running Kubernetes instead of Marathon.
We're actually running both of them on the same cluster, so you can choose which one you want to use. Yeah. Yes, you.
So how do you upgrade Kubernetes? Is it in place? Will I lose my containers which are running? Another question was, if I needed to add something to the API server, extended scheduler or admission control, etc. So how do I do that here? Because if I'm just clicking a button, I don't have access to those, or change the policy.
Yeah. So in general, right, it's 100% the same Kubernetes. So you can do the same thing you would normally do. You get to talk to all the APIs. Nothing's locked down or anything. So you can do it just the same way. Yeah.
So I have a question on the previous item you showed. Basically, I see that installing Marathon app for package beta Kubernetes. So what does it mean? Like I thought Kubernetes is deployed through Marathon. Like, is it not true?
That's right. So let me show you what that means. So the piece that Marathon runs is this thing down here. So this scheduler that basically provisions all the Kubernetes components and that upgrades them and that heals them, that's one container that runs in Marathon.
Okay, so if I were to upgrade, let's say, Kubernetes installation or Kubernetes package, I would basically deal with the one which you are highlighting right now.
So you would do it. We don't have upgrade fully done yet. It's in beta right now, but I can show you. Let me show you what it looks like to add some kubelets. It's basically the same process that you would use to upgrade it. So if I go into this options file and say, let's say I want to start 10 instead of 5 kubelets, and then we're going to use the CLI. Just copy my command here. So to do an update, like I said earlier, you get this Kubernetes subcommand for the DCOS CLI. So you say DCOS beta Kubernetes -- name, that's just the name of this cluster. update start, and then pass in the options file. So you would do the same thing for a version update. We just haven't built that piece yet. But yeah, so you pass in this options file, and then we should see filter for kubelet. We should see in a few seconds, we should see more kubelets pop now.
Actually, I have one more question. So what do you think is the value proposition in the long term as Kubernetes starts supporting some of these workloads that are not natively supported by Kubernetes now? Like if there's an HDFS implementation, is there value in like running 2 stacks?
Yeah, I think there's definitely value. So so first of all, these things have been running on Mesos for a long time. So there's some production experience with these things, and and the experience that you get here really is like on a public cloud. You get packages, you get a CLI sub command, right? So it goes beyond just starting these things up. So it's really just kind of this end-to-end experience with the CLI, managed packages, with managed upgrades, things like that.
What's the overhead cost of running both Mesosphere and Kubernetes?
The overhead, I mean, Mesos itself uses 100 megs of memory, I think, less than that. And I mean, it just runs everything in containers. Containers have very little overhead, right?
That service catalog thing that you just showed.
Yeah.
Is that a Helm-based catalogs? If it's not, how easy it is to extend those catalogs?
It's not Helm, but it's similar. So to create your own package in there, you basically have to write 3 JSON files. One with how do you bring up the container, one with some package metadata, like who's the author and so on, and then one with the configuration options you want to expose. Yeah, and to be clear, you don't have to put everything into that catalog. So the catalog is really for these packages that have a scheduler, that have a CLI. If you just want to run a Docker container, you don't have to build a package. You just run it similar to how you would run it on Kubernetes, just using the CLI, bring up the app. That's it.
Question over here, Toby.
How do we go about installing this on-premise data center with no internet connectivity? This is like the customers asks that they don't want to expose the data centers to the internet. How do we pull the images and stuff?
Yeah, very familiar with that problem with data centers that are cut off from the internet. So you can, the DCOS install is it's one big file you can download. It has all the pieces. You can then, we built a simple installer in-house, or you can automate it with Terraform or Puppet or pick your tool, completely offline. And you can basically create an offline version of this catalog also. So it can be run completely, cut off from the internet.
Does it also come with, Docker images that is needed by Kubernetes installation, like API server or scheduler? Does it come with that?
So yeah, what I showed here in the public universe, it just pulls down the Kubernetes images that Google publishes. But behind a firewall, you would just point it at a container registry that you run internally. Yeah.
I have a question here. When you're installing, say, Kubernetes and Cassandra, do they share nodes ever, or are they going to go on different nodes?
So they can share nodes. It sort of depends on how many resources you want to give to Kubernetes or kubelet. So when you install a package, you can say, where is it? So you can just set the memory settings and CPU for the C groups. And so depending on how much you set there, it's either has the entire node or a fraction of the node.
Question. So on the Mesos side, how do you scale in terms of, I know you're just running in a single machine of your Mesos.
So this is actually, I'm running, let's see what I'm
How many machines you have in the Mesos side?
So here I have 11 nodes. So I have one master and then 11 agents in this case.
Okay. Yeah. So is there any specific best practice available? Like, when people talking about microservices are very small content, right?
Right.
We come from an enterprise-grade company where a ERP machine is 300 GB RAM required, a 300 GB disk required. So have you ever done any kind of best practices or some sort of a foundation that, hey, if your organization looking about this many microservices running with this container and you require this many bunch of nodes in the Mesos,
Yeah.
Is there any kind of scaling being done?
Just sort of best practices, numbers on how big of a node you need. Is that the question? Yeah. Well, it really just depends on what you run on top. So, you know, some applications need a lot of memory, some need a lot of CPU. Just depends on that. Yeah.
I think it might make sense for you to continue with your presentation, so you can actually get to like show
so
everything
many
you
great
got.
questions, but I'm not going to get to
and you're probably going to be
content.
here right after the talk too. So
great. So let's see, a couple of things I wanted to show you. So like I said, this is a fully configured cluster. We saw that it's HA. It has 3 of all the master components, and it's secure by default. It also comes with a bunch of goodies. So we're looking at the Kubernetes UI. Heapster is installed here. kubedns is installed. The dashboard, of course, that we're looking at. So really, goal is to get you up and running quickly with everything. Just to prove that this is actual real Kubernetes without modifications. So kubectl create. I just have some simple pod here, except the file doesn't exist. It's called something different. Here we go. So you can use the same kubectl commands. While this is deploying, let's do something fun. Let's kill one of the etcd nodes and see how it recovers. So if we go here, so etcd obviously important. It's the brain kind of. So we have 3 etcd peers here, and I'm going to look at those tasks here. So what I'm going to do is pick one of the etcd tasks and attach to the container. So you can do a DCOS task exec to this thing, run bash. And then I'm in the container, and I'm just going to kill the etcd process, 19. Boom. So it's gone. But again, so what happens now is it doesn't just bring up a new etcd container. It also, tells the 2 existing nodes that this other peer, this other etcd container, is now no longer there, and forget about that. And here's another one. So it does all the cleanup actions. And so this is really important, right? This you need that to be highly available, to be self-healing. And there we go. It's back. You can actually do. Oh yeah, there was a question earlier around. Let's see. I lost the command. What I want to. Yeah, never mind. I wanted to show how the node came back. But we just have to look at logs for that. So yeah, so this is important, right? Any component that might go away here because a machine fails or whatever, the cluster can heal itself. What showed the update? So it's really easy to add new kubelets as your cluster grows. Oh yeah, here's the command. I really need my script so I can cheat. So what we showed earlier was I added a few kubelets, right? And so I scaled the cluster from 5 to 10 kubelets. And I just want to show you what this scheduler that I talked about, what this looks like internally. So it has this notion of different groups of nodes, or we call this a plan. And so this is how the system thinks about it, right? It brings up etcd first, and 3 peers in there, all those created. Then API server, controller manager, scheduler, and then the kubelets, or the nodes, which consist of kubectl and kubelet. So it really, the scheduler has this whole plan of how to bring up all these different nodes, and then also how to replace them and how to add nodes to one of these pools. Okay, I think that's it for my presentation. I'm probably way over time already. So any other questions? Maybe 1 or 2, and I'll answer the rest afterwards. Yes.
The kube scheduler, are you planning to replace that? The DCOS scheduler?
We're not planning to replace the kube scheduler or any other piece of Kubernetes. No, we want it to be 100% vanilla Kubernetes, changes whatsoever. What DCOS does is it provisions Kubernetes in a production-grade way. It makes it secure by default. It it hooks it into the networking, It makes it self-healing. It lets you scale it up easily and lets you upgrade it easily. Yeah. There's a question back there.
Yeah, I have a question about the sorry, the when the etcd node was or peer was killed. You said there were some cleanup actions. So are you saying that there's something calling into the etcd APIs and removing the member and adding?
That's
correct.
Member? Yes.
What's I guess what component is actually calling into the API?
So that component is that's the scheduler process that you see here, which is just called Kubernetes. So this one scheduler, this initial scheduler process that we brought up, this uses you know, an API that we have in Mesos. We call it a two-level scheduler concept in Mesos. So you can build these application-aware schedulers that know how to heal etcd, that know how to heal Kubernetes or anything else. And so this initial process, it got notified by Mesos that one of the etcd tasks went away. And so then it, you know, basically looked into its plan, which you can think of like a run book. Like, okay, what do I need to do to replace a etcd node? Okay, first bring up etcd container, then tell the two other peers that, you know, the old peer is away, and you know, tell them about the new peer.
Is this scheduler open source by any chance?
It's open source. Yeah.
Okay. Thanks.
Mm-hmm. Yes. To leverage, so which service catalog?
Let's say the one that DC was offering, Mesos was offering.
Yes.
And then as part of Kubernetes, I want to services use some of these.
Yeah.
Do I have to have two service catalogs, or can I also use the one which is all the equipment?
So these things that are in this catalog here, they are specifically built from Mesos. That might change over time. Maybe we'll add some, you know, Helm charts in there, for example. But right now, these things are all Mesos native things. Yeah. Mm-hmm.
I was curious if you could elaborate on the networking a little. I noticed you had a persistence layer adjacent.
Yeah.
How does service discovery interact? Can my Kubernetes-based application discover that adjacent?
Yeah. Let me I actually totally forgot to show that. So DCOS has a built-in, you know, it's a virtual IP-based service discovery system. So there's a subnet you can configure, and it just draws virtual IPs from that pool. And it'll then do, you know, internal east-west load balancing and service discovery with these IPs. We actually use this to assign IPs to pods also. So let's look at a pod. Describe pod. So so you can see the pod IP comes from that DCOS network, and this is what makes it so it can, you know, talk to other services running on DCOS, and other services can talk to Kubernetes workloads. They use the same network, and in fact, so there's also we call them name-based VIPs, but basically they're host names and ports that that the service discovery system maps to these IPs. So in this case, you know, the argument for this pod is -- Cassandra host. And it's this host name that it uses to find Cassandra. So what happens under the covers is this host name maps to a 9.IP. That 9.IP is part of the virtual network. And so we intercept the SYN packet that goes to any IP in that subnet, and then route it to the actual endpoint. So the actual, you know, host IPs in this cluster are probably 10. Yeah, so these are the actual host IPs. So the DCOS service discovery system maps these virtual IPs, which are static for each service, right? So the Cassandra will always have the same virtual IP, or any container you start yourself will have the same virtual IP for as long as the service lives. So if you deploy a new version of the container, it'll stay the same. If you scale up that container, all those extra containers are going to be reachable behind that same virtual IP, because you know, DCOS does the mapping and the load balancing. So there's two options. There is an overlay network. It's based on VXLAN. That's optional. That's just if you want isolation. The default, like what I'm showing here, that's just service discovery, and it's based on IPVS. Yeah, but VXLAN is optional. Yeah, it obviously has a performance hit, and so that's why it's optional.
My question was, you said that you're putting Kubernetes into one container of Mesos. So what kind of container you're talking about? Is it Docker container, C group, or just a conceptual level container? So if it's Docker container or C group, then you're trying to nest a C group inside Kubernetes or other thing built upon Kubernetes. So did you experience any C group nesting issue?
So here's how it works. So we use the official Kubernetes Docker images. We actually have our own Docker runtime. So that's how we run those. So we will pull the images, the Kubernetes images from the Google Container Registry, but we run them not with a Docker daemon, but with our own container runtime. And so let's say we start a kubelet container, and then within that we start a containerd. And so anything that kubelet wants to start, it starts with containerd.
You just said you have.
Let him go first. I'll do you next.
Sorry, to follow up on the one before this. So when you were showing how Kubernetes could access Cassandra from here, is there any tracking of like these, I don't know, cross services within DCOS? Because I mean, I can see like, oh, I set up a Cassandra, but I don't know it's being used by some container in Kubernetes, and then I make a change, and then suddenly that virtual IP is no longer valid or something like that.
Got it. Yeah. So you might be able to get that from some low-level API, like what connections are open and things like that. What you have here is, here's some overview. So you have these name-based virtual IPs, what we call them, these service addresses that you can look at in the GUI, and it just shows you successful connections, failed connections, and latency. So for example, the Kubernetes API server gets exposed like this as well. And then you can see here, like, what are the actual endpoints and hosts and ports that it load balances to. So in this case, the 3 API servers that we provisioned.
Question, is there any extensibility into public cloud or roadmap for hybridity approach?
Yeah, so it can already run on any cloud. And there's some things on the roadmap to, say, make it easy to manage those things and burst.
Thank you.
Yeah. Yes.
For Kubernetes, they have their DNS resolve, like their service name default. For DCOS, here looks like DCOS they have their own like DNS resolver, or they share each other.
It's shared. So Kubernetes can resolve the same names that any other workload on DCOS can resolve.
Okay.
Yeah.
Good. Thanks.
They share the same DNS resolver.
Yeah. With a Cassandra-like installation, is there a way, say you're running a 3-node Cassandra cluster, is there a way to specify that you want the 3 nodes to be on 3 physically different nodes or on 3 different racks?
Yeah, so 3 physically different nodes is the default. And there is a way, so Cassandra has rack awareness. There's a way to configure that as well. Yeah. So if you look at the 3 nodes, you see different host IPs here. So that happens by default.
With Kubernetes, you can create an external persistent volumes and access them with whatever APIs. Can these volumes be used by the DCOS? Is there a separate API available for DCOS?
So DCOS also supports persistent volumes. And actually, we're working together with the Kubernetes team and with EMC and Pivotal and others in the industry to standardize on the same interface for interacting with storage. Container storage interface. So that's in progress right now. I think the spec is done. Everyone's working on code now. So it will be soon. It will be all the same interface.
So I have one more, probably like a deeper question in that, like as an upstream Kubernetes maintainer, we just assume that kubelet gets to own the whole node. That's like an assumption into every design decision that's being made. In this case, you're running but like layering kubelet as a container. Have you run into any issues, or have you just like, are you just like in the day zero scenario now that you don't have enough experience yet?
Yeah, I'd say it's young. It's a beta, right? What we're going to do is we're at least initially going to recommend that folks run only one kubelet on the node and nothing else. And then, we'll keep an eye on it and see if it makes sense to share the node. I mean, for dev test, it definitely makes sense, but for production, we'll see.
Have you experienced any kind of clusters in two different data centers? And have you experienced any kind of latency between? I know you just mentioned you're running on VXLAN, and then have you done any kind of simulation between two data centers, running two clusters, and your workload moving between one data center to another data center? What kind of latency you have found? Any difficulty running your workload?
Yeah.
Typical, like what the other friend just said, you have a hybrid cloud or maybe some kind of federation method, whatever.
Yeah. So DCOS itself is fairly resilient to higher latency. It uses an actor model to communicate between the agents and the masters. So it's just message passing. It can tolerate latency. Between the masters, it's a little different. They have a replicated log, so latency really matters there. I mean, what I'd recommend is that you only run a cluster per physical location. We do have folks though that have say all the masters in the data center and then a bunch of agents, and then they have other agents in a cloud with direct connect or something like that. So yeah, you can do that. I mean, it's really the question is what kind of HA guarantees do you want, right? If you lose your data center or you lose your fiber between your data center and your cloud, do you want both of those things still to function fully? Then you need to run two separate clusters.
For Kube Federation? Yeah.
There's going to be some federation support is coming, yeah.
All right, that is the last of the questions. Please see Toby at the end. What we're going to do right now is take a quick break. Feel free to get some more food. Also, really quickly, I did not personally thank VMware and Mesosphere, so thank you very much to both. Yes, definitely. Also, if we do have any upstream contributors in the room, I'd love to talk to you.
Resource operator and its own management network.